long form of periodic table. So mostly done a cathode ray experiment. This experiment shows a relation between frequency of X-rays, is related to the charge present on the nucleus. Of a atom. So that means mostly given a relation square root of frequency equal to A into Z minus B. Here nu is the frequency of X-ray line, and Z is atomic number, and A comma B are constants, and a plot between square root of nu and Z given as a here we are taking on y axis we are taking square root of nu, on x axis we are taking atomic number, then we can get a straight line. Suppose if you take atomic actually here this graph showing relation between square root of frequency and here this is atomic mass. Then we can get a curve. Actually, see this one, students. Based on these two graphs, he mostly explained when we take a square root of frequency and atomic mass. Atomic mass is taken on x-axis, square root of frequency is taken on y-axis. Then we can get a curve. That means there is no proper relation between atomic mass and square root of frequency. But if we take this series first graph, suppose if you take square root of frequency on y-axis and atomic number on x-axis, we can get a straight line. This straight line gives a relation. That means it follows the atomic number only. So element is characterized by its atomic number, not by atomic mass. Is it okay, students? So he given a conclusion based on these graphs. This indicates an element. An element is characterized by atomic number, not by atomic mass. So based on atomic number we can define the element properties, but not using atomic mass. So based on that he given a statement. What is that? Is periodic law. So mostly periodic law. So what he given is The physical and chemical properties. The physical and chemical properties. The physical and chemical properties of element. Are periodic functions of their atomic number. Atomic number. Actually here atomic number means there is nothing but number of electrons. There is nothing but number of protons. Based on electronic number of electrons, we can write the electronic configuration also. So that's why we can change this. We can modify this periodic law also. Instead of atomic number, we can write electronic configuration also. Because based on number of atomic number, that means number of electrons, we can write the configuration. So the physical and chemical properties, the physical and chemical properties of element are periodic functions of their electronic configuration. So instead of atomic number, I wrote electronic configuration. So next we will discuss the main points of long form periodic table. So main points of long form of periodic table is elements are arranged in the increasing order of atomic number. Next, second point is it has 7 periods, 18 groups. So in this periodic table, period number indicates that the period number indicates outermost orbit number. That means valency orbital. Next one is fourth point. Elements after atomic number Z equal to 92 are known as. So the elements after atomic number 92 is known as transuranic elements. Transuranic elements or synthetic elements. And these are all are radioactive elements. Next, fifth point. So normally in long form of periodic table, 8, 9, 10 groups are combinedly called as eighth group. And next, sixth point is below 92, below atomic number 92, man-made elements, that means synthetic elements. Man-made elements are technetium. So T atomic number 43. So technetium means Tc, atomic number 43. And the second one is promethium. Promethium. So promethium means PM 61. So PM atomic number 61. So these two elements are man-made elements below atomic number 90. Next, seventh one. So actually cerium to lanthanum. Cerium atomic number 58 to lutetium 71. These are called lanthanides. So it is third B group, sixth period. Third B group, sixth period. Similarly, thorium Th92 atomic number, lawrencium 103. These are actinides. So these are third B group, seventh period. And also here students, here in this case in periodic table, first period is known as shortest period, very short period we can call shortest, because number of elements are 2, hydrogen and helium. And the next, second period and third period is known as short period. Actually, we can call the first one as a very short also. Very short period or shortest period, because it contains only how many elements? 8 elements. 8 elements. Next, fourth, fifth period is known as long period, because it contains 18 elements. And the next one, sixth period. Sixth period is very long period, because it contains 32. Actually, seventh period also nowadays, this seventh period also now contains 32 elements. So now this one also very long period only. Determination of position of elements in a long form of periodic table, LPT, long form of periodic table. So in this first one is the black of element. How to find out black of elements? So actually, on the basis of type of orbital, in which last electron enters, that is that black. Suppose if last electron enters into the s orbital, that is s black. If last electron enters into the p orbital, that is p black element. So we can find out the black elements. We can find out the black elements based on last electrons enters into the in which orbital. Next, second one, period. How to find out period? Principal quantum number. Based on principal quantum number. Based on principal quantum number of a outermost shell. Of a outermost shell. We can find out the period. We can find out the period. Next, C. Group of the element. How to find out the group of element? So we are finding the group. So how to find out group? If last, suppose we will take some examples. So if last orbital has 1 or 2 electrons, if last means if last orbit, if last orbit has 1 or 2 electron without d electrons, then their group number is either 1 or 2 without d electrons. Suppose if last orbit has 3 or more electrons with 10 d electrons in n-1 shell, then their group number in their group number in number of electrons in outermost plus 10. Suppose 3 or in last orbit 3 or more electrons is present in a d orbital, d electrons, that means d subshell, then number of electrons in outermost plus 10, that is the group number. Suppose last orbit has 1 or 2 electrons, here 3 or more electrons. Suppose it has less than 3 or 3. So if last orbit has 1 or 2 electrons, has d electrons in n-1 shell, then their group number is number of electrons in outermost shell plus number of electrons in n-1 d. So this is the formula, students. So how to find out group? If the last orbit has 1 or 2 electrons without d, so if 1 electron is present means that is first group. If 2 electrons are present means that is second group. Suppose along with 3 electrons, along with d orbitals. If only 1 or 2 electrons in a d orbital, then how to find out group is number of electrons in outermost shell plus number of electrons in n-1d. Suppose more than 2, that means 3 or more electrons are present in a d shell, then group number is number of electrons in outermost plus 10. So this is the formula, students. So based on this formula, we can find out the group IUPAC nomenclature for unknown elements. Actually, digit, Latin word. Before writing names, we must know the Latin words and abbreviation. So actually here, digit 0, nil, small n. So 1, 2, 3. So 1 means un. U, symbol is starting letter U. 2 means by, starting abbreviation is B. 3 means try, T. 4 means quad, so small q. Quad, small q. 5 means pent, P. 6 means hex, H. 7 means sept, S. 8 means oct, O. 9 means N, small e. So based on this, we can give the IUPAC name. Actually, only elements after 103, atomic number 103, IUPAC names are given. IUPAC names are given. So elements with atomic number 103, after the elements 103 only IUPAC names are given. So now atomic number Z. Atomic number Z. So IUPAC, actually this is IUPAC temporary name, because at the time elements are unknown, temporary. And next IUPAC approved. So here students, so already I said of elements with atomic number 103, after that only IUPAC names are there. So 101, 102, 103, there is no names, we should not write, even though we know symbols. So for this they are given as name as Mendelevium. Mendelevium, symbol MD. Next, so you should remember these names with the symbols also, because in previous exams also they are given one time. So 101, Mendelevium, MD. Next 102, Nobelium, NO. Next 103, Laurentium, LR. Next 104. See the students, 104 means 1 means un, 0 means nil, 4 means quad, and finally we should add IUM. IUM. So simply symbol is UNQ, 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 and its name, after that they find out Rutherfordium. So they given name as Rutherfordium, RF. Next, 105. 105 means, see the students, 105 means this is un, 0, nil, 5 means pent, IUM compulsory. So UNP. So we can write this one as UNP. And its name is dubmium, dubmium, DB. Next, 106. 106 means UN, nil, hex, hexium. So UNH, and it is given as Seaborgium, Seaborgium. Symbol is SG, symbol is SG. Next, 107. 107. Un, 0, nil, 7, septium, septium. So UNS, UNS. So it is borium, borium, BH. So 108. 108 means nil octium, nil octium. So UNO, Hasium. Hasium means HS. Next, 109. 109 means nil, Nium, UNE. So metinium, metinium. Symbol is MT, symbol is MT. Next, 110. So 110 means, students, nil, 0, nil, nilium. So UNN. So its name is Dermstadium. Dermstadium. Simply DS. Next one is 111. 111 means EM. So simply triple U. Triple U means Rondgenium. Rondgenium. Rondgenium means RG. Next, by UM. By UM. So UUB. So UUB means Copernicium. Copernicium. symbol is Cn. So 113 tritium. So UUT. UUT means nihonium. Nihonium. So NH. Next 114. 114 means unquardium. UUQ means flerovium. FL. Similarly, only two elements. So see the students here. 115. 115 means unpentium. Unpentium. So UUP. So its name is Moscovium. So MC. And 116. 116. So 116 means unhexium. So its name is Livermorium. Symbol is LV. Next 117. 117 is septium. Its name is tennessine. TS. Next 118. 118 means unoctium. Its name is Oganesson. OG students.